So today I'll be discussing a third grade lesson plan in math, where students would be focused on determining the unknown, the unknown whole number in a multiplication equation. So before we begin, the students' prior knowledge should consist of adding and subtracting whole numbers, as well as multiplying and possibly some division. Some of the vocabulary that I determined, this may be stuff that they already know, but I think it's good to refresh anytime that you're going into a lesson. So an equation is a statement that the values of two mathematical expressions are equal. So basically, they're usually set with an equal sign, and what's true on one side needs to prove true on the other for it to be an equation. And of course, a whole number is just a number without fractions. So to begin the lesson, I would pose a word problem, and as you can see, the problem states, Jose has 15 pieces of candy to give away. He would like to give each of his 3 friends an equal amount of candy. How many pieces of candy will Jose give to each of his friends? So by starting the lesson with this word problem, I would begin by using a number talk, because I think that those are, they prove to be beneficial, and students can kind of bounce ideas off of one another. And I just think that altogether it kind of helps the class as a whole. So something I might do to facilitate that number talk is just to find some key information in the problem that would help them solve it. So of course they would be giving me some of these answers, but I would maybe be prompting them with questions. So, you know, what is the total number that we're looking at in this word problem? And we can see that that is 15 pieces of candy. Who is this problem about? Because sometimes it helps to just kind of really break that problem down so they can see the important information. So we know that it's about Jose. Do they necessarily need that to solve the problem? Not really, but again, I think that it does help to have the important information pulled out. What is this? What are we trying to find in this problem, or what do we want to know? And that is how many pieces of candy he's giving away. For the number of groups in this problem, because it is multiplication, we want to, this may take some back and forth on their part. It may or may not. They may just pop off with the correct answer, which we can see here, it's 3 friends. That's the number of groups, because he has 15 pieces of candy total, but he wants to give them away 3 times, and that is the number of groups. Our group size, we don't know, because that's what we're trying to figure out. It's how many pieces of candy. So the group size is unknown, and that's what we're working on today. And we're going to do that using equal groups. So another vocabulary term, just to, again, possibly refresh, equal groups is having the same number of items. So every group is going to have the same group size. They'll be equal. And unknown, of course, it's an unknown quantity. It's what we don't know. It's what we're trying to figure out. So looking between the word problem and the important information that we have pulled out, we can go ahead and write an equation. So we know that our number of groups is 3, because there are 3 friends that he wants to give the candy to. We don't know how many pieces each friend is going to get, and that is the unknown number. And there is a total of 15 pieces. So this is what we're trying to solve for. So at this point, after the number talk had finished, I would pass out either blank sheets of paper, or they would have individual dry erase boards that they could utilize. And I would begin by having them all draw out our number of groups. So we have 3, and I would just have them draw some circles. You know, these are going to represent Jose's friends. Pardon me. So we know that Jose's friends are gonna each get pieces of candy. So what I would have them do using 2 color counters, I would just have them distribute these one at a time among each group until they had a total of 15. So as they were placing these, they could possibly count one at a time as they went, coming to 15. Sorry, I'm getting ahead of myself here. And basically by the time that they were finished, they would be able to see that each of Jose's friends receives 5 pieces of candy. So nobody gets more, nobody gets less, everybody has the same amount. And we can plug that in to the equation, and if they, knowing prior knowledge and knowing some of that multiplication, they'll know that 3 times 5 is 15. They can see that visually represented here, and so that is the lesson. I would do some repeated instruction where we work through a few of these together. You could also, if you wanted to try a different scenario, you could use the same problem and just maybe tweak a few of the numbers and have them try and work through it on their own. So I would just come up here to the problem, and we would say Jose has 12 pieces instead of 15, but this time he has 4 friends. So just to save time, I won't go through the counters again, but we could add a second group. We could add 3 more counters, and they would eventually see that 4 friends would then get 3 pieces, and so on. So I think plugging some of this information in again is kind of what helps them to see that. And of course, the manipulatives help when they have an actual visual representation. Another example that maybe some of the more advanced students could do if they finished would be to try and figure out how many counters I pass out to the class. Now, this might be getting ahead of ourselves because it's 2-digit, but I think it would help them to see that these are evenly divided into group sizes, number of groups. It's something they could actually, touch and hold and eventually count out if they needed to. But the number of groups, let's say just hypothetically, I've got 3 bags, and each bag has 20 pieces. So they have a number of groups, they have their group size, and that is just one more in-person example that they could have a look at. Sometimes manipulatives are not always available for students that are trying to work through a given problem. Of course, for this lesson they will be, but let's say they take it home and they're doing homework, I would go over and maybe show them with the worksheets that I hand out, show them that they can draw it out. Sometimes just being able to see a photo instead of the words can help. And we would work together on this first problem anyways, kind of as I was scaffolding the guided practice. They could then finish this first worksheet in pairs or talking, but the first one we would work through just so they would have another example. So it says Mr. Smith drives a total of 10 miles to work each week. So let's get Mr. Smith in his car here, and he's driving a total of 10 miles. And this is just going to break it down as we go so that they can actually see. If Mr. Smith goes to work 5 days per week, so we'll say it's Monday through Friday just so he can have the weekends off. If he goes to work 5 days per week, how many miles does he drive each day? Now, by providing this visual representation, they can still see that it's going to be equal groups and that we don't always have to have counters or counting bears or Cheerios or anything like that. We can solve the problem just by using what we know and sometimes drawing it out does make it easier. So Mr. Smith is in his car, he drives 10 miles total, and we want to figure out how many he's driving each day using equal groups. So all we would do is put a tally on each day. So they can go back and see that's only 5 miles, and we know our total is 10, and that's not going to cut it. So we go back, we add 2 more, or we add 1 to each day, excuse me, and then we have 2 miles each day. Well, if you count those, you can do repeated addition to figure out that that does equal 10. But again, we were working on multiplication, so the equation would look like this, and we're trying to figure out the group size, which was the total miles Mr. Smith drove each day, which is 2. Once they finish the guided practice worksheet, we would then have a third worksheet to help them kind of explain their understanding of the concept. So an example of that might be, if every spider has 8 legs, how many legs will 4 spiders have? So they have an equation presented to them, 8 times 4 equals blank, and they can explain if that multiplication problem is correct or if it's incorrect and why. So that will give me, as a teacher, the knowledge and it will just help me to know that they understood it. And again, I would be circulating through the class, helping them with their colored counters and answering any questions that they might have. Thank you.